Okay, so when we are looking for the vertex, if they don't give us the graph, then we would just convert our equation into vertex form. But luckily, we don't have to do that here. So when they give us the graph, what we're looking for is the vertex. It makes more sense when you know that the vertex is, in simplest terms, just the highest and lowest point of the graph. Okay, so if you look at where that arc is on the graph, that point right there at the bottom, if you zoom in and you look at the coordinate units, you're going to see that it's going to be -1, -5. Okay, so to find the x-intercepts, think about it like this. When it comes to the x-intercepts, you're going to set your y equal to 0. Okay, when it comes to the finding the y-intercept, you're going to set the x equal to 0. So basically, whichever intercept it is that you're looking for, you're going to set the opposite variable equal to 0. So if we're looking for x, we set y equal to 0, okay? And vice versa, for looking for y, we set x equal to 0. When we're looking to solve for the x-intercept, we're going to focus on this part of the equation right here, okay? We've already set the equation equal to 0 because this is y. We're going to go ahead and solve it using the quadratic formula. This is simply the work being shown, okay? Now, when we have the square root of 40, I drew this extra part down here just to explain how we simplified the square root of 40 to 2 times the square root of 10. It's because we're going to do what we call we could call it a tree, where basically we're going to use our perfect square roots. 2 times 2 is 4, 3 times 3 is 9, and so on and so forth. We're going to use these to break down the square root of 40. How do we do that? Well, basically, you're going to see if any of these numbers, any of our perfect squares, can fit into our radicand, okay, which is 40 right now. So right off the top, I know that 40 can be divided by 4. So I'm going to break it down. I'm going to say 4 times 10 gives me 40, okay? Then I'm going to break down 4 because, again, 4 is a perfect square, and now we have 2 and 2. The reason that we're looking for a perfect square is because in order to get from underneath this radicand, this square root sign, the number on the inside, there has to be 2 of the same numbers, okay? So another way to write 40 is 4 times 10. Okay, well, that's still just a 4 and a 10 under the radical, okay? But if I replace this 4 with the 2 times 2 times 10, well, now I have two 2's. I have a pair of 2's, which means now it can move from the inside to the outside. Okay, what do you have a pair of? A pair of 2's. 10. How does this work? Well, we would say 2 squared gives me 4. 4 times 10 gives me 40. Okay? So that's how we get this answer here. We're going to continue to solve our work. Now, when you see these fractions, you're going to simplify, okay? 4 goes into 4. This is going to, we're dividing by 2. We have a 4, a 2, and a 4. The common factor between those is a 2. Okay, so we're going to divide all the fraction parts by 2, which is why we end up getting a 2 here, -2, and that 2 right here ends up disappearing. All right, now your work says find the lowest and highest point. This is going to be the lowest point because think about it, it's plus or minus. Whenever you subtract something, it becomes the lowest. Whenever you add something, it becomes the highest. Now, when we're looking for the y-intercept, it's saying to set it equal to 0. Set x equal to 0. So if this is our equation, we're going to use our x equals 0, plug it in, and we're going to end up getting y equals -3, which if we write it as a unit term, a unit point, we're going to get 0, -3, okay, because that's our y value. They also want you to find the minimum and maximum value. So how do you know if you're looking for the minimum or the maximum value? Well, you know by looking at your a in your equation. Up here, you can see that the equation, and I wanted to show you the equation written out like that. This is the same form, okay, right here. So this is when we say a, this is what we're referring to. This first coefficient right here, okay? If this a is negative, then we're looking for maximum value. If it's positive, we're looking for minimum value, okay? Just right down here. If a is positive, we're looking for minimum. If a is negative, we're looking for maximum, okay? It's kind of backwards, okay? Because you would think, well, if something's less than 0, wouldn't it be smaller? No, but we're going to flip it, okay? So we know that we're looking for the minimum value. We're going to use this equation right here, negative b over 2a, and solve. We get negative 1. All right, there we go. Let's see. If they were asking for the actual unit point for the minimum value, then you would find y by plugging negative 1 into the function, but they don't, so you're okay. But here's the work just in case you want to look at it. Again, if you had to solve this question and they said write the unit point and not just the value, then you would plug in negative 1 into the function to find y. Okay, because remember, a function is just a machine where when you give it an x, when you put in the x in the machine, it gives you a y. Okay, so if you're ever looking for a y, you have to find the x to put in first. Okay, so that's why we found our x first to put in order to produce our y. Perfect. Now, it wants us to find the domain and range. Remember that domain and range is just another fancy word for saying x values and y values. Okay, domain and range are asking about, well, the ranges on the graph. For a domain, you're going to be asking, well, how far left does the graph go? How far right? Because our graph looks like a U, we know that it's going to keep expanding left and right, okay, for infinity. But our range asks how far up and how far down. How far down and how far up. We want to say it in the order of negative to positive because that's how we're going to write our answer, okay, in interval notation form. So we say how far left, negative infinity, how far right, positive infinity, and this is typically your answer when they're asking you for the domain for these, okay? But for the range, it's how far down and how far up. Looking at the graph, the lowest point that the graph goes is at negative 5, okay? Remember, y value. Look at the y-axis. Look at the y-axis. Where's the lowest point that the graph touches? That negative 5 point, okay? And the highest point is also infinity. Because we don't know. Notice that we use a bracket to write our answer versus a parentheses because the negative 5 is an actual point that you can tell someone, hey, like to go stand at. You can mark it versus all these other points, they're just kind of assumed, okay? They're infinity, they're marked, okay? So you don't have to worry about that, about getting those confused. It's really simple. When we say included, it just means that it's the mark point. You might also see a closed circle compared to an open circle, but that's the only difference between a bracket and a parentheses, okay? An exact point and a kind of given point. If you have any questions, definitely let me know. And yeah, I hope this helps. It makes sense. Thank you.